The probability of a certain set is nothing but the size of the set divided with the total size of the sample space. When you will learn probability in details, you will understand this. So therefore, for equally likely, that is called the classical probability, finding a probability is equivalent, mathematically equivalent, to finding the number of elements of a set. And finding the number of elements of a set is nothing but permutation, combination, combinatorics, they say. So therefore, combinatorics is the first step towards probability because it teaches you classic. It's nothing but classical probability. Okay, so that's the beauty of it. That's why you need to learn it in such details. That's why it's a part of probability.
Hello, guys. Welcome to Chinta's School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
So let's n be this. It's a these are digits. A B C D are digits. It's given digits, but not necessarily distinct. And they can be same too. Only the condition is that A is not equal to 0. This makes sense because if A is equal to 0, it will not be a 12-digit number. So therefore, this condition is equivalent to this condition. So what is important is that when you're solving a problem, you should understand what are the pieces of information given and whether they're equivalent or not. Okay, what does it imply? And when you understand what does it imply, you can translate to a dimension, to a space, the information that is compact, that no overlapping information is there. So when you solve a problem and see you have used just the first 3 information and not the last 4, and you cannot solve a problem, that's where you need to understand that, oh, I probably didn't induce the 4th information to solve the problem. And that's where I need to understand that. And then you will understand, oh, what to invoke more, what to do more. You understand? So that's why understanding each and every piece of information is very important. That's why you have to first understand what the problem means, what each and every problem means. So if n is equal to this 4a, so I divided into 4 of them because 4 for each, because it just looks good and it just makes sense. So it says it divisible by 45, but the digits a, b, c, d are not necessarily distinct, and a is not equal to 0. How many such numbers are there, right? So a is not equal to 0 means that makes sense, where a, b, c, d are not necessarily distinct. Okay, so an a, b, c, d can take. So therefore, first option is that when you're counting, the first option is you have to understand a, b, c, d all has to come. So a has to come from 9 options, like a is less than equal to n and greater than equal to 1. And B, C, D, each one of them can be less than equal to 9 and greater than equal to 0. So there are 10 options here and 9 options here. But it doesn't sound that easy because there's a divisibility option. If this divisibility option was not there, then you could have easily said that, oh, there are 9 options here, 9 options here, 9 options here, 9 options here. So there are 12 nines and 3 tens. So it will be 9 to the power 12 times, 12, 9 to the power 9 and 10 to the power 3. If the divisibility by 45 was not there. Did you understand that? Each of them has 9 options. A, 9 A's are there. So it's 9 to the power 9, and B, C, D, they can be 0. It can take 10 values. So 9 to the power 9 into 10 to the power 3. Did you understand, Mega? Okay. So, but it is not there. So of course it will be less than that, right? So, and you have an option of divisibility by 45. So therefore it's asking you, it's pushing you to understand that what does it mean, the relationship between divisibility by 45 and the digits, right? That's what it's asking you to. So what does it mean to be divisible by 45? Divisible by 45 means it should be divisible by 9 and should be divisible by 5. Now if it's divisible by 5, you know what is the condition on the digit that should be divisible by 5, guys? What is the condition of the digits that a number should be divisible by 5? So this should be 5 or 0. So therefore, you have reduced down the space. So there are 2 options here. Now, it's not over. There are not probably 2 options here. There can be less. Now, the condition is that divisible by 9. What is the impact on the digits? What is the relationship between the digits? Or what are the constraints on the digits that make it divisible by 9? A number is divisible by 9 if sum of all the digits is divisible by 9. The reason is very simple. Let's say if you have the digits a2 dot an, these are the digits of a number. You can write it like this, right? This digit means 10 to the power. So it's like n plus 10 times 10 to the power 1 times an minus 1. So last one will be 10 to the power a1, 10 to the power n minus 1 times a1. So this is the digit format, right? When you expand it, right? Now you see that if any 10 to the power thing, any 10 to the power minus 1 is always divisible by 9, right? Because a to the power n minus 1 is equal to a minus 1 into dot something. And if a is 10, so a to the power n minus 10 to the power n minus 1 is equal to 9 times something. So it's divisible by 9 always. So therefore, you can what you can do is that you can make everything like 10 to the power n minus 1 minus 1 plus 1. You can make change to like this every each one of the 10 power. So what happens is that you are left with some multiple of 9 plus a1 plus a2 plus a dot an, some multiple of 9 plus this. So therefore what happens is that this number is divisible by 9 if and only if this is divisible by 9, because there is also an addition of divisible by 9, multiple of 9. So therefore a number is divisible by 9 if and only if the sum of the digits is divisible by 9. Therefore the sum will be divisible by 9. Now let's see. So there are 9 a's, so 9a plus b plus c plus d. This should be divisible by 9. And since 9a is a multiple of 9, this implies that 9 should divide. This is a symbol for division, b plus c plus d. And d should be 0 or 5. Therefore, 9 should divide b plus c, or 9 should divide b plus c plus 5. So two options, right? So let's do it once for b plus c and once for b plus c plus 5. So b plus c can take how many options? B plus c, b can be so first of all, 9, this can be, am I doing anything wrong? So one thing I did a mistake in the previous one, it should not be 9 to the power 9 because these are not distinct, right? It should be just 9 for one first. That was a mistake. It should not be 9 to the power 9 because if it's 9 to the power 9 means the first one can be 5, but the second one cannot be 5. It can be 6 too. But no, they are the same. So it should be 9. It's a block of A, right? It's 9 times 10 times 10 times 10. Do you understand what was my mistake, guys, in the previous one where there was no condition of divisibility by 5? So therefore, that was a mistake. So now 9 divides b plus c plus d. So 9 divides b plus c, or 9 divides b plus c plus 5. So for b and c can be anything, right? So b plus c can be anything less than equal to 18 and greater than equal to 0. So b here, therefore how many options here of b and c together? Because b plus c together can be 18. B and c together. Yeah, let's see how many b plus c options are there. So either b plus c is equal to 0, means both of them 0, or b plus c, let's write it down properly. So we have the 9 divides 9a plus b plus c plus d, and d must be equal to 0 or 1. So the 0 or 5. So this means that 9 must divide b plus c plus 0, or 9 plus must divide b plus c plus 5. This is what 9 must do. And we know that b and c, we know that a is less than equal to 9 greater than equal to 1, and b as c is less than equal to 9 greater than equal to 0, right? So therefore a can be anything. That's what you understood. A can be anything. So just constraint on b and c. So now let's understand b plus c can be less than equal to 18 and greater than equal to 0. So and b plus c plus 5 is less than equal to 23 and greater than equal to 0. So therefore in this, so there are two cases. So let's write them differently. They are distinct cases. So we have to do them differently. So in this case, so therefore b plus c can be equal to 0. So let's make this blue. B plus c can be equal to 9. B plus c can be equal to 18. And here also same, because it's between 23, right? Perfect. So now let's count it. There will be the same, right? Whatever the number is here, it will be the same here because just the distinction has changed. The numbers will be the same. Yeah, b plus c plus 5 should be equal to, cannot be 0. So it should be 9, 83, 18. So b plus c plus 5 must be a multiple of 9. So therefore b plus c plus 5 must be equal to 9 or 18, cannot be 0, right? So this will not be same. That's why it's different. So yeah. See how I mean, that's why you need to do it carefully. So b plus c is equal to 0 can be only one option, 0, 0 of b, c. B plus c is equal to 9 can be quite a few options, right? 0, 9, 1, 8, dot dot dot, 8, 1 and 9, 0. That means if you fix the first one, the rest will be fixed. And the first one options is 9 options, right? 10 options. So 10. If the first you fix first one, the second one is fixed. So 10 options. Okay, it's one option. And similarly, b plus c is equal to 18. For b plus c is equal to 18, the only possibility is 1 because 9, 9. So here it is 12. Let's see here. B plus c is equal to 4. Again, for 4, there can be, so here it means that b plus c is equal to 4, and here it means that b plus c is equal to 13. So b plus c plus 4, b plus c is equal to 4. The b can take from 0 to 4, right, at max. So 5 options. And for b plus c is equal to 13, b can take from 0 to 13 at 0 to 9 at max, right? So therefore 9 options. There's an issue. It's not symmetric. Am I doing things right? Okay, b plus c is equal to 13 is a bit tricky because b can take from 0 to 9. You can say c will take for 0. Okay, no. B plus c is equal to 13 means b can take from 4 to 9 and c can take from 9 to 4, right? So it's symmetric now. So that means 4 to 9 means 6 options. So it's 6. Did you understand how we are calculating? We're not using any formula. We are just, there are formulas for there. Okay, we are not using that. So what we need to do is that how many pairs of B and C are there that does this, right?
Okay.
So why we need to? Because essentially we need to find how many pairs of A, B, C, D are there, right? To see what's happening. Now what we have done, we have boiled down to seeing how many pairs of A, B, and C and 0, and A, B, and C and 5 are there. One is this, one is this.
Correct.
And we will adding them, right? Now to see A it is not dependent on A. So A can be anything. So that is already 9 is up there.
Correct.
Yeah. So we are therefore trying to find how many pairs of B and C are there that satisfies this. Now how many pairs of B and C are there that satisfies this. So for how many pairs of B and C and there such that it satisfies that 9 divides B plus C is nothing but B plus C can be 0, B plus C can be 9. How many pairs of B and C? We are counting how many pairs of B and C are there. So for B plus C is equal to 0, only one pair, 0 and 0. For B plus C is equal to 9, 10 pairs, 0, 9, 1, 8, 2, 7, dot, 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 8, 1, like 7, 2, like it will be reflected. So essentially,
Right.
you put B to be anything from 0 to 9, and the C will automatically adjust it to make the sum 9. So there are 10 options. We can take all of the values, right?
Okay.
Similarly, for B plus C is equal to 18, there is only one pair, 9, 9, nothing else. So
Yeah.
therefore 1. So total 12 pairs.
Mm-hmm.
So therefore this part, it's 9 into 12 with D is
Okay.
equal to 0. And for this
Correct.
part, we are again counting. We want that B plus C plus 5 is to be divisible by 9. That means B plus C plus 5 can be 9 or 18 because that's the maximum value they can take to be divisible by 9. It cannot
Okay.
take 27, B plus C plus 5, right?
Mhm.
So
Correct.
therefore, we will now count B plus C plus 5 is equal to 9, which is equivalent to counting B plus C is equal to 4. So now for B
Okay. We
plus C,
subtracted 5 from this. Okay.
yes, because B can take till 4, 0 to 4,
Mhm.
and C will
Correct.
automatically adjust that. And similarly, but what if B plus C is equal to 13? For B plus C is equal to 13, you cannot start from B is equal to 0 because C will be 13. So you have to start from such a B that so that C is at max 9. That means you have to start from 4. So and you can go till 9 because C cannot be at max because B cannot go beyond 9. So therefore 4 to 9, that is 6 options, right? 4, 5, 6, 7, 8, 9.
Correct.
Therefore
Okay.
here 11 options. So 9 into 11. So essentially total 9 into 12 plus 11, which is 9 into 13, which is I think 114. No, 107.
23, right?
Oh, we are doing something wrong. Oh, 23. I'm so sorry. Yes.
9 into 12 is
Yeah, so 207. So yeah, that's great.
Hmm.
So you understand how we do it step by step. And now why combinatorics is important for probability and even for data science, why they're doing it. Because you will see that for equally likely events, it's equivalent to doing counting the number of elements in a set. When you do, when each of the value is equally likely, the probability of a certain set is nothing but the size of the set divided with the total size of the sample space. When you will learn probability in details, you will understand this. So therefore, for equally likely, that is called the classical probability, finding a probability is equivalent, mathematically equivalent to finding the number of elements of a set. And finding the number of elements of a set is nothing but permutation, combination, combinatorics, they say. So therefore, combinatorics is the first step towards probability because it teaches you it's nothing but classical probability. Okay, so that's the beauty of it. That's why you need to learn it in such details. That's why it's a part of probability. So I hope you enjoyed that. I hope you understood that.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.